Wouldn't it be better if the drone could go out, autonomously fly around the thing being inspected, autonomously identify faults in the bridge, for instance, because we've taught it through deep learning what these faults look like, take high-resolution images of just those faults, and then bring them back to the operator so that they can be scheduled to be fixed.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello everyone, this is Randy Goers, and welcome to this special InterDrone segment of the Drone Radio Show podcast. I spent 4 days at InterDrone 2016 and met up with some amazing people doing some amazing things with drone technology. I've prepared a series of short podcasts so you can hear the latest product announcements, advances in technologies, and trends that will interest you. In this segment, we'll hear from Jesse Clayton, Head of Business Development for Autonomous Machines at Nvidia. Jesse has over 20 years' experience in technology spanning software, GPU computing, embedded systems, and aeronautics. His current focus is bringing advanced computer vision and deep learning solutions to autonomous machines and intelligent devices. At InterDrone, Jesse spoke on a panel on the future of chips and sensors powering next-generation drones. I caught up with Jesse, and we talked about Nvidia's role and advances in the autonomous vehicle industry. Let's take a listen.
My name's Jesse Clayton. I'm the Senior Manager for Product Management for Intelligent Machines at Nvidia. So I'm responsible for drones, robots, and other intelligent machines.
What is Nvidia's role in the drone industry?
Sure. So Nvidia is probably best known for gaming and computer graphics. But what Nvidia really builds is a high-performance, general-purpose parallel processor. So that enables us to solve problems in high-performance computing and also in artificial intelligence. So the same GPUs that are powering gaming systems are also powering some of the world's fastest supercomputers and data centers, and now autonomous machines like robots, cars, and UAVs. And so part of my role is understanding where deep learning and other related technologies can help UAVs.
So from a hardware standpoint, is some of the components that NVIDIA makes, are they actually on the drone?
That's right. So NVIDIA makes a product called Jetson. So this is a small module. It's about the size of a credit card, and it runs under 10 watts. And the idea about Jetson is that it can bring deep learning to run directly on drones, robots, and other small machines. So deep learning is a very powerful technique. It can be used for image classification, for natural language processing, and it's really being shown to be capable of solving many problems that haven't been practically solvable in the past. Jetson is what allows you to take deep learning and actually deploy it into these devices.
How does deep learning work on a drone? Is the drone learning, or are the users learning as a result of using it?
Deep learning, there's really two pieces to it. Deep learning is a neural network-based approach to machine learning. And I'll give you an example in probably the most researched area in deep learning, which is image classification. So with deep learning, the first step is training. And in training, you're showing the neural network many, many instances of the thing that you want it to learn. So if you want it to learn what cars look like, you show it lots and lots of pictures of cars, and you tell it these are cars. Show it many, many pictures of pedestrians, for instance, tell it these are pedestrians. And through that process, it learns how to distinguish one thing from another. After the training process, you can then deploy that model that it's produced to do the second part of deep learning, which is called inference. In inference, you're showing it things that it hasn't seen before, and it can draw conclusions from those. So you show it a picture of a car, and it'll tell you that that's a car. Now, in drones, this has a lot of different applications. So take, for instance, industrial inspection. Drones are a great platform for doing things like inspecting cell phone towers, wind turbines, bridges. But the challenge right now is that they can't be widely deployed because there are only so many pilots that are capable of flying around these things. And piloting close to these things without crashing into them is a relatively difficult thing. Wouldn't it be better if the drone could go out, autonomously fly around the thing being inspected, autonomously identify faults in the bridge, for instance, because we've taught it through deep learning what these faults look like, take high-resolution images of just those faults, and then bring them back to the operator so that they can be scheduled to be fixed.
So is deep learning already available in the market, or is it still in the research phase?
Deep learning is available in the market. There's a lot of research going on right now. Say all of the big companies in tech and in related industries are developing their deep learning strategies right now. Deep learning is really affecting every industry, and the serious players in those industries are having to come up with their strategy, because if they don't, they're at the risk of being left behind. So deep learning today is solving problems in medical diagnosis, for instance. It's solving problems in anomaly detection for managing large time series data. And now we're applying it to autonomous machines like self-driving cars, drones, and UAV and robotics.
What makes Nvidia unique or special in developing deep learning technologies?
We're really three things that have led to the development of deep learning. The first is new algorithms for training deep learning neural networks. The second is the existence of very large data sets for doing the training. So because there are so many more sensors in the world, there are big companies collecting large data sets of data, there's much more information available for the training of these neural networks. And the third big thing is GPUs. These new algorithms are parallel in nature, and so they need a general purpose parallel processing architecture to be able to run efficiently. And so Nvidia develops GPUs for deep learning. So everybody that's serious about doing deep learning right now is doing it on Nvidia GPUs. And so it makes sense that we would apply that technology to every different area that we touch, including autonomous machines.
What are some of the biggest challenges in applying the technology to drone systems?
One of the challenges is deep learning is very computationally intensive. And so it takes a platform that has a lot of performance to be able to do this. Now, Jetson has over 1 teraflops of performance, and it can do it in under 10 watts. From a power efficiency standpoint, there's nothing that's even close to it that can be deployed to a drone. And so with Jetson, you can actually deploy deep learning in a package that is both small enough and power efficient enough to do deep learning on the drone itself.
Okay, just so I have it, the drone has everything on board to actually learn by interacting with its environment without any user input.
That's exactly right. And so whether it's looking for faults in infrastructure, or whether it is identifying inventory in a warehouse, or if it's looking for a specific type of plant for doing precision agriculture, the decision making is on board the drone itself, and deep learning is what makes that possible.
If I'm someone wishing to buy a drone with that type of technology in it, say for the infrastructure inspection, what do I look for on a drone to make sure it has that?
Our customers right now are largely still under development and applying deep learning to these problems in these different spaces. I expect over the next 2 to 3 months, you'll see a lot of announcements of UAVs that have Jetson in them and are doing deep learning to solve some of these problems.
Any applications that you can talk about that have been successfully deployed at this point?
Not yet. So we just launched Jetson at the end of last year, and since that time our customers have been doing their development.
What brought you to InterDrone this year?
One of the things that we wanted to tell people about drones, we found that many of the people that we're talking to, they're really interested in deep learning because they believe that it can solve problems that they have and their customers have, but they don't understand how to get started. And so one of the things that we wanted to do at InterDrone was come here and tell people, one, about deep learning, but two, that it's a very accessible technology. And many drone companies, in fact, I would guess almost all of the drone companies that are here at InterDrone right now, they already have the resources on staff to be able to do this. So if they have a clever engineer that they can spare for a few days, in fact, they can go and develop a deep learning demo running on Jetson to demonstrate how they might be able to use deep learning, and then figure out how they could apply that to the problem that their company specifically focuses on. So that's kind of why we wanted to come to InterDrone this year. One, to tell people about deep learning, and two, to show them how accessible it is and that they can get started. They already have the resources in-house to do it.
How do they contact, or how do they get involved actually?
So Nvidia sells a developer kit for its Jetson TX1. It's called the Jetson TX1 Developer Kit. People can buy it off of our website, or they can buy it off of Amazon if they would prefer. We also sell it through different outlets around the world in different regions. So that's the first step. And then Nvidia provides all of the collateral, so all of the tools, the SDKs, the hardware design files. It's all publicly available. So developers can go from an idea all the way to a finished product without having to make a round trip and get on the phone and track somebody down to get help from. All the information is publicly available. So that's how they would get started. In fact, Make Magazine just published a project last week where they showed how to do deep learning. They developed a cat detector and entertainer running on Jetson. And of course, with Make Magazine, anybody can follow along with the project and implement the same thing. So just in a couple of days of that engineer's time, they can go from their Jetson to developing a deep learning demo in a matter of days.
Has Nvidia done this before in other types of applications?
No, we wanted to do something a little bit different with Jetson, and the reason why is that we realized that with Jetson in the UAV and embedded space, we tend to have a large number of smaller customers. And so whether it's a startup or a guy in his garage or a researcher, we wanted to make it possible for all of them to succeed. And so that's why we decided to make everything publicly available.
And where does Nvidia see itself in the drone industry as the industry itself continues to evolve?
So we're really focused on problems in autonomy. So making it possible for drones to be able to make decisions on boards, to make drones intelligent. So problems that can't be solved, or problems that really need that level of capability in order to be solved, that's where we're going to be continuing to focus. So some of the ones I mentioned, industrial inspection, precision agriculture, surveillance and security, warehouse management, package delivery. Those are all problems that we believe the best solutions will have the intelligence on board, and so that's where we're going to be focusing.
And how far out in the future do you think we are before we start seeing some of these advanced levels of autonomy or applications of learning?
Yeah, so I think specifically in the UAV space, it's likely to happen. I said there's going to be some announcements in the next couple of months, so we'll start to see the early signs of that. But there's lots of work that's public already on deep learning right now in self-driving cars, in image processing, in medical diagnosis. So we're already starting to see the signs of these solutions being deployed. I expect we'll see some things specifically on UAVs in the near future. Anything
that I missed that you think that we should be talking about?
No, I think we covered everything. I mean, the big things that we're trying to get across is everybody should really be taking a serious look at deep learning. It's affecting almost every different industry, and the significant players in this industry need to be working on their deep learning strategy, or they may be at risk of being left behind. And the second thing is that deep learning is accessible. People already have the resources in-house to get started using it.
That's it for this InterDrone segment. I hope you enjoyed hearing from Jesse Clayton of Nvidia and hearing about the exciting advances in deep learning and drone technology. I want to thank Jesse for spending a few minutes with me at InterDrone. If you want more information on Jetson, check out the Nvidia website. Thanks for listening, and I hope you'll download other InterDrone segments, as well as the General Drone Radio Show podcast, to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.